Alright, what's up guys? In this video, we're going to pick up with some multivariable calculus, and we're going to be talking about vector value functions. So we're asked to evaluate the definite integral of this vector function. So it's going to be the definite integral from 0 to 1, 6t cubed I minus 9t squared j plus 25t to the fourth k integrated with respect to t. So the way you evaluate a definite integral of a vector function is really no different than how you do it for an indefinite integral. When you take the limit of a vector function and derivative of a vector function, you basically integrate each component of the vector function with respect to t from 0 to 1. So if you were to think about that vector function r of t as, let's say I have the integral from a to b, and I have r of t that I want to basically integrate with respect to t. And again, I'm integrating a vector function. Well, then you just basically integrate from a to b, and we'll call this f of t. You'll integrate that with respect to t, I, and I'll put it in parentheses because we need to have the unit vectors out there. Then it'll be the integral from a to b, and it'll be, I don't know, I guess we can call this g of t, I guess, with respect to t, and that's j. And then it'll be the definite integral from a to b, and it'll be, I guess we can call this h of t, I guess, integrate with respect to t, and then k goes out there. So you basically just integrate each component, if you will, of the vector function with respect to t from 0 to 1. Now this can be done with indefinite integrals as well. I should probably do a video with indefinite ones as well. So that's what we'll do. So really what we're looking at is the integral from a to b, or in our case, we can say the integral from 0 to 1 for r of t with respect to t. So that's just the integral from 0 to 1, 16t cubed with respect to t. I, now in this case, we got a minus and not a plus, so we'll just make the notation change there. And then on the outside here, it'd be the integral from a to b. I meant from 0 to 1, sorry. And it's going to be 9t squared integrated with respect to tj. And then our last one is plus the integral from 0 to 1. And it's going to be, what's that, 25 t to the fourth dt, and then k. Remember, we don't need a plus c because these are definite integrals. Now, if we were doing indefinite integrals, we would essentially have three constants, c1, c2, c3, but you could combine the constants. Basically, that the 1c absorbs all of the constants, but we don't need constants here. So let's just deal with the first one. Obviously, this is very easy. Sorry, I was a little not very neat over there. I apologize. So this was 16t cubed integrated with respect to t. So 16 comes out front. This is t to the fourth all over 4 from 0 to 1. So this is 1/4 minus 0, which is 1/4. So we'll get 16 times 1 over 4, which is just 4. So that's what the value that we get for the first integral from 0 to 1. The second one was from 0 to 1, and this time it was 9t squared with respect to t. That's just going to be 3, but I'll show you how to do it. That's going to be 9t cubed all over 3 from 0 to 1. This 1/3 minus 0, which is 1/3. Then we'll take the 9 times the 1 over 3. And yeah, that's just 3. Now, again, once you've gotten to multivariable calculus, which is when you'll start learning this stuff, or maybe Calc 2, because some professors do stick vector functions in Calc 2. I didn't learn about them until Calc 3. But as you can see here, when we break them up, the integrals that we're doing, we're breaking up the pieces, are first semester integrals at best, even though they're definite integrals. I know you don't learn definite integration in Calc 2, but they're easy integrals to evaluate. So as you can see, now this won't always be the case. So don't expect to get an easy, to evaluate an easy definite, or evaluate multiple pieces of your vector function from A to B. And don't expect to always be easy. That's my point. Professors tend to shake things up. And then the last one was from 0 to 1, and this was 25 t to the 4th. And that's just going to be 5. But again, we'll do it. So we get 25. And this is t to the 5th all over 5. That's from 0 to 1. So that's 1/5 minus 0, which is 1/5. And then we got 25 times 1 over 5, which is just 5. Okay. So the way we write our final answer is this way. So we're asked to integrate from 0 to 1, 16t cubed I minus 9t squared j plus 25t to the 4th k. We're asked to integrate that up with respect to t. And so our answer to this is just going to be 4i minus 3j plus 5k. That's the answer. And that's how you do it. And I'll post a video with us doing it for indefinite. We probably should have done that first. I did do a video of taking derivative of a vector function, which is essentially, again, like I said at the beginning, the same thing. You just take the derivative of each piece of the vector function with respect to whatever variable is being used in that case, which is typically going to be t. But that's your answer. So let me know if you got any questions about how I arrived at it, and we'll go from there. I'll see you guys next time.